Welcome to ICT with Miss Ushani YouTube channel. This is the part 2 of programming. Right. So, in our previous session, we discussed what an algorithm is and what the type of control structures are. Right. So, now we know what an algorithm is. How do we write one down? We can't just write a messy paragraph, no? We need a standard way that anyone in the world can understand, right? In computer science, we use two main tools, flowcharts, which are like visual maps, and pseudocodes, which are simple English instructions, right? So today we will learn how to use both. So the purpose is to make the algorithm easy to read, understand, and translate into a computer program, right? It is a proper guidance to write a computer program, right? So, let's look at flowcharts first. A flowchart shows the steps of a program in a visual way. But we must use specific shapes for specific jobs, right? So look at this chart. This oval shape is only for the start and the end, right? And the parallelograms are for inputs and outputs. And rectangles are for the actual processing or calculations, assigning values, right? Those kind of things we do using process box, right? So, the diamond is very important. It is used whenever the computer needs to make a decision or a choice, right? With this decision box, we ask questions and make decisions, right? So, Pute, how do we know the next steps? By arrows, right? The arrow shows the direction, right? And this is the connector. It connects part of a large flowcharts. We use it when the flowchart get larger, right? So here is a simple flowchart for finding the area of a circle, right? So this uses a sequence control structure, right? We discussed about three types of control structures in our previous session. This is the first type, right? Sequence control structure. Notice the shapes, ovals for start and end, parallelograms to get the radius and show the area, and a rectangle in the middle to do the math, the calculation part. The arrows shows a straight line downwards, meaning the computer just follow the steps one by one without skipping anything, right? Here we can't skip any step, right? Think here. If we skip this second step, can we have the output? No, we can't do the calculation without the radius, right? So we can't skip any step, right? So that is a sequence control structure. Right. Here, let's look at a selection flowchart. Selection control structure. Right. This is about decision making. Right. So, we want to know if a number is odd or even here. Right. We input the number. After starting, we input the number and our process is dividing it by 2 to find the remainder. It is the process. We show it using the process box, right? A perfect rectangle. So, the computer asks using this decision box, is the remainder 0? Is the remainder 0? If yes, what happens? Prints even, right? If no, the flow goes another way to print odd, right? So, this is how a computer makes decisions. Understood? So, this is the algorithm related to this flowchart. You can check one by one, step by step, right? Here, the third structure is repetition. This is a loop. You can see until the condition becomes true, we have to go back again and again, right? This is called repetition. Imagine adding up a long list of numbers. We start with the total of 0, right? We start here with the total of 0, right? Then we get a number, right? Number as n. So, here, add it to the total. When get a number, add it to the total, right? We add this n to the total, right? And here, then the diamond asks, are there any more numbers? If yes, if there are more numbers, we have to choose this path, this yes path, right? So, if yes, the arrow loops all the way back up to get the next number, right? It keeps spinning in the loop until the answer is no. And then it finally outputs the grand total, right? So, this is the algorithm of it. You can check also the flowchart with this algorithm, right? To understand step by step procedure, right? So, moving to another topic, introduction to pseudocodes. Pute, drawing shapes takes time, no? Drawing shapes takes time. Professional programmers often prefer pseudocodes, right? So, pseudo means fake or imitation. Fake or imitation. It looks like computer code, right? It looks like computer code. It uses keywords like in code. But it's just simple English, right? Because it's not tied to a specific language like Pascal or Python. Anyone can understand it and translate it later. We use capital letters for the main action word, right? Here you can see some common keywords, right? We use capital letters for these keywords like begin, end, input, read, get, so on, right? So here, as you can see, we use begin and end for the start and finish. Input, read, get keywords are for getting data, for inputs, right? Output, display, print, show. These keywords are for showing results. Process, calculate. Keywords are for doing math or calculation part. It is for the calculation part and the actions. So, you can see here the selection keywords and the repetition keywords, right? So, let's start with a simple calculation. A simple example for simple pseudocode example. To calculate the area of a circle, right? This is a sequence structure, right? Because we can't skip any step, right? We just follow the lines from top to bottom. First, we need the radius of the circle from the user, right? Then the computer does the math using the formula. What is the formula to calculate the area? Here, right? So, this is the formula for calculating the area of a circle. And then, after the calculation part, finally, we show the result to the user by this display keyword. This is an output keyword, right? And notice we use begin and end to show where the program starts and finishes, right? So, yes. Moving to another example. Now, let's look at decision-making example, right? Selection control structure. So, we read the number and divide it by 2 to find what? To find the remainder, right? If the remainder is exactly 0, the computer follows the then path and say it's an even number. Otherwise means else, right? Otherwise, it says it's an odd number. Every if must have an end if like this, right? We end the if statement by this end if keyword, right? So the computer knows the decision part is over, right? So moving to the repetition part. But sometimes we need to repeat the steps. No, this is called a loop, right? We call this a loop. Here we start with a total of 0, right? Total equals 0. we tell the computer to repeat 2 steps. What is steps? Read something and calculate something, right? We start by the repeat keyword, and now let's look at what should we repeat, right? First, we should read the number. Let's take number as n, right? According to this example. So, now we should calculate the total, right? The current total is 0 and we should add this n value to the current total, right? So, it keeps doing this until there are no more numbers left. We keeps doing this until there are no more numbers left, right? Only when the numbers are finished does it move to the next line to show the final total, right? Here we show the final total by using this display keyword. Understood? So, let's turn to yes, somewhat yes. In this example, we use a while loop. As you can see, here we use while loop because we know exactly how many times to repeat. 10 times. There are 10 inputs, right? It is the given instruction, right? So, we use a counter called n, right? N is a counter to count how many times we considered the inputs, right? So, yes, we use a counter called n that starts at 1, right? Here you can see at the beginning, total equals 0, average is equal to 0 and n is also equal to 1, right? N equals 1, right? So, now we should consider n equals 1, right? N equals 1. So, you know, we should repeat this until n becomes 10, right? So, for now it is 1. Here we should, every time we add a number, we add 1 to n, right? As n equals n plus 1, right? Until n becomes 10, right? So, when n becomes 11, the loop stops, right? So, then we calculate the average by dividing total from n minus 1. We stopped the loop when n becomes 11. 11 is a false value, so we should reduce 1 from the current n value. N minus 1 equals 10. That is the value we consider for the loop. So, you know how to calculate an average, no? We have to divide the total by the count. We do this until n becomes 10. That is why we divide the total by 10, right? Okay. And finally, we can display the output. Right, as the output, we have to display total and average, right? Okay. Now, Pute, to understand these codes, you must understand variables. Right? Think of a variable like a labeled box. In our average program, total is a box where we keep adding more numbers, no? N is a box where we keep track of the count. We initialize them at 0. So, we start with a clean slate. We start with a clean slate. When the values inside these boxes change, the computer can solve complex problems. Right? So, now let's practice converting a real life flowchart into code. Right? So, in our making tea example, if the tea isn't sweet enough, you add some sugar and style. We do the same thing until the taste is good. When the taste is good enough, the flowchart says the end. In pseudocode, we use while loop. Here, right? Add sugar, style tea, and finish the end the while loop by using end while keyword. Right? This shows how everyday actions follow algorithm logic. Right? Uh, Here I have mentioned the conversion steps. Start and end in the flowchart shows the begins and end in the pseudocodes, right? And here, look at this diamond shape, the decision box. Instead of that, we use in pseudocodes this while loop, right? This while loop to repeat an action for the repetition, right? It is a loop. So, you can see the actions inside this rectangle, inside this process books, right? You can see those actions as simple English instructions here, 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 and here, right? So, to convert any flowchart, you just match the shapes to the keywords, right? A diamond always, here also the diamond, yes, diamond always becomes an if statement, right? In this example, we compare N1 and N2, right? We compare N1 and N2. If N1 is bigger, it is stored in the large variable. If not, N is stored there. Finally, we display the whatever is in the large box as the output, right? Again, we can see instead of start and end, instead of this oval shape, we use begin and end keywords in pseudocode, right? And instead of this input and output, we have used read and display keywords here, right? And you can see the processors actions as simple instructions, English instructions, right? So, next, so this is a great example because it uses everything we have learned. No, to find the smallest number, we start by reading the first number and putting it in the box called min, right? This is, yes, in the flowchart, you can see those are inside this process box, right? So, here you can see those are just simple English instructions, right? We assign n to min, right? So, we also start a counter at 1, right? This is also a process box. Remember it, right? Think according to the flowchart, right? So, here we start a while loop to get the rest of the numbers, right? Inside the loop, we get a new number, right? We get a new number. We use a selection statement. It is if here, right? So, to compare it, right? We take this if keyword to compare something, right? We should compare this value. We ask, is this new number smaller than the one in our min box? Right? Is it smaller than current min? Current min value means, this is the min means minimum value, right? So, if it is true, right? If the answer is yes, we throw away the old number and put the new smaller number into the min box, right? We add 1 to our count here and repeat this until we have checked all 10 numbers, no? See here, the while the condition is count smaller than 10, no? So we have to repeat this until count becomes 9, right? When the condition is true, we have to end this while loop by using this end while keyword, and then the print the minimum value. Minimum value means min here, right? That is how we print the smallest one we found. Here, this table is your translator's guide, right? Just like translating a sentence from Sinhala to English, you can translate a logic map into a logic script, right? So, your logic map is the flowchart, and logic script is the pseudocode, no? So, you can do this following these simple rules. Oval shape. The oval always represent the boundaries of our program. No, when you see an oval at the top, you write begin. When you see the oval at the very bottom, you can write end. Alright, it tells the computer exactly where the instructions start and where they stop. Right. So here is a parallelogram, right? Think of the parallelogram as the communication shape. It is used whenever the computer talks to the outside world, right? If the arrow is bringing data into the computer, right? If it is bringing data into the computer, use words like input or read and get, right? If the computer is showing a result on the screen, if it is showing an output, use this display output print show keywords, right? Simple. And next, the rectangle. The rectangle is where the hard work happens. It is used for calculations or for giving a value to a variable, for assigning a value to a variable. In your pseudocode, you will use, yes, words like calculate or set, process, yes, right? For example, if you see a rectangle with math inside, you write calculate area equals length multiplied by width, like that, no? So, here, the diamond for selection, right? This diamond is used for selection. Diamond is the most important shape because it represents a choice. In pseudocode, we translate this using the if then else structure, right? And we should end the statement end the selection by using this end if keyword, right? Okay. Pute, when you see a diamond with an arrow, right? When you see a diamond with an arrow that loops back up to an earlier step, it represents a repetition, right? Depending on the textbook example we discussed earlier, we use while or repeat, no? We used while, repeat, keywords. So, you can use while if you want to check the condition before doing the task. You can use the repeat until if you want to do the task first and then check the condition. This keeps the computer working on the same task until the goal is reached. Right? To make this easy for you, you can use this chart. Right? You can go through the flow chart. Every time their feet step into a shape, they must look at this table and pick the matching word. If they follow the shapes in order from top to bottom, the pseudocode will practically write itself. Simple, right? So, okay, this is the end of today's session. So if you have any doubt, you can drop a comment message into the comment section. Okay, Putte, let's meet again with part 3 of programming. Until then, like the video and subscribe my channel. Thank you for watching.